Every night, the moon gently guides our darkest hours, shaping tides, inspiring dreams, and quietly anchoring our sense of stability. But what if, without warning, it simply vanished? The sky would shift in ways we can barely imagine, altering the very fabric of life on Earth. As we explore this sudden emptiness in the night sky, you'll see how something so seemingly distant holds the power to reshape the world, and perhaps remind us just how fragile our place in the universe truly is. The moon's role in Earth's natural history. The moon has been a silent witness to Earth's tumultuous history, its gravitational pull shaping the very fabric of our planet's development. Long before humans looked up and wondered about its origins, the moon's gravitational influence was subtly yet persistently guiding processes that have rendered Earth hospitable for life. Its tug creates a gentle, rhythmic pull on Earth's crust and oceans, leading to the tides that ebb and flow with a hypnotic predictability. These tides weren't just about water levels. They played a key role in stirring the oceans, mixing nutrients, and fostering early life forms in coastal environments. Without the moon's steady dance, the Earth's surface might have remained a static, less nurturing landscape, less capable of supporting the vast diversity of ecosystems we see today. Imagine Earth spinning alone through the vast emptiness of space, a solitary planet without its celestial companion. The moon acts as a cosmic stabilizer, preventing Earth's rotational pull from wobbling chaotically. This stabilization has allowed a relatively stable climate over millions of years. Without the moon's gravitational grip, the Earth's tilt could vary wildly, leading to extreme climate shifts, possibly making conditions too volatile for stable life to flourish. Locked in place by the moon's gravity, the tilt ensures consistent seasons and climates, giving life time to adapt and evolve. The rapid, unpredictable shifting of Earth's spin would make ecosystems fragile, and life's delicate balance would be far more tenuous. Beyond physical stability, the moon's presence has indirectly influenced the evolution of life itself. Its steady, predictable cycle acted as a natural clock, possibly shaping biological rhythms. Our own circadian rhythms echo this lunar influence, even in modern days. Organisms in early Earth environments relied on light and dark cycles, which the moon helped to regulate. Without such lunar cues, evolutionary pressure might have taken a very different course, potentially stunting the complexity seen in life forms today. The moon's absence might have led Earth down a path where life struggled to develop the intricate cooperative behaviors that define us now, leaving a planet that perhaps remained barren or inhospitable over millions of years. In the grand sweep of Earth's natural history, the moon's presence isn't just a pretty celestial feature. It's an essential element in the story of our planet's stability and capacity for life. Its disappearance would leave Earth a different, far more fragile world, vulnerable to chaos, climate extremes, and ecological instability. That realization stings with a quiet awe for how interconnected and delicate the universe really is. Humanity's fragile existence relies on tiny cosmic coincidences, and the moon's role in our history highlights just how thin that thread of stability truly is, urging us to cherish that fragile balance we often overlook. Gravitational relationship between Earth and Moon. The gravitational pull between Earth and the Moon is a dance that has shaped our planet's very existence. Like two magnetic poles tugging on each other in a cosmic tug-of-war, they exert forces that influence each other's movements. The moon's gravity creates a noticeable effect on Earth's waters, pulling them into two bulges, the familiar high tides, one facing the moon directly and the other on the opposite side. This tug also affects the Earth's crust, causing minor deformations and contributing to geological processes. The gravitational force doesn't only affect water and land. It subtly impacts Earth's rotation, gradually slowing down our day length over millions of years. If the moon suddenly vanished, this delicate gravitational relationship would unravel in seconds. The immediate consequence would be the disappearance of the tidal bulges that govern ocean currents and marine life cycles. Without the moon's gravitational influence, high and low tides would cease, plunging coastal ecosystems into chaos. Marine animals that depend on predictable tidal patterns for spawning or feeding would suddenly find their rhythms disrupted. The absence of those gravitational pulls would also mean the Earth's rotation might no longer be subtly slowed down, potentially causing slight changes in day length over very long periods. But the most immediate effect feels like losing a silent partner that keeps the seas in harmonious balance. Earth's orbit, which is maintained in a specific path partly because of the moon's gravitational tug, might also begin to change if the moon disappeared. The moon acts like a stabilizing anchor, helping keep Earth's axial tilt steady. Without it, Earth's tilt could wobble more freely. Imagine a spinning top wobbling erratically as it slows to a stop. Such instability would lead to irregular seasons and unpredictable weather patterns, which in turn could impact climate stability. The gravitational link is a kind of cosmic glue, weak in comparison to the sun's gravity, but crucial for maintaining a delicate balance that allows life to flourish. On a more poetic level, the sudden loss of the moon would strip away one of the universe's gentle reminders of interconnectedness. The moon's gravity has been subtly shaping Earth's core, tides, and climate for billions of years, quietly reminding us that nothing is isolated in this universe. Its disappearance would not just be an astronomical event. It would echo across the fabric of life, throwing years of equilibrium into chaos. In losing the moon's pull, we would be reminded anew of how fragile our existence truly is, tethered, perhaps more than we realize, to something far greater and beautifully complex than our everyday perception. Effects on tides and ocean currents. The moon's gravitational pull is the heartbeat of ocean tides, constantly tugging at Earth's waters and shaping their movement. Without the moon, the rhythmic rise and fall of tides would vanish almost instantly. Instead of the two daily high and low tides that we're accustomed to, the oceans would settle into a much calmer state, driven solely by the sun's weaker influence. This shift would be stark. Tides would diminish to a fraction of their current heights, perhaps only a few inches instead of several feet. The graceful ballet of the sea, where coastal ecosystems rely on this regular rhythm, would be thrown into chaos. Tide pools, which host a delicate balance of life dependent on the ebb and flow, could shrink or even vanish, disrupting entire food chains that have adapted over millennia. Ocean currents, which are largely driven by differences in temperature and salinity, both influenced by the distribution of solar energy, would also be disrupted. The gravitational effects of the moon help create subtle but persistent variations in water density and movement. Without that lunar influence, the complex dance of currents like the Gulf Stream would weaken. These currents act as massive conveyor belts, transporting warm waters from equatorial regions to higher latitudes, and cold waters back toward the equator. They regulate climate, making some areas milder than they would otherwise be. Removing the moon's pull would dull these currents' intensity, potentially triggering a cascade of climate shifts. Temperatures in places like Western Europe, which rely heavily on warm Atlantic currents, could drop significantly. The disappearance of the moon would also change the stability of the ocean's layers. The gravitational forces help maintain a balance that prevents mixing from becoming too vigorous or too sluggish. Without these subtle nudges, stratification, the layering of water based on temperature and salinity, might become more static or irregular. This can starve the deep-sea ecosystems of nutrients that usually get stirred up by currents, ultimately sealing off some marine habitats from the surface life they depend on. As a result, productivity in fisheries could plummet, and life deep beneath the waves might struggle to survive. A less dynamic ocean would be less resilient, more fragile in the face of changing conditions. In the grand scheme, the removal of the moon's gravitational influence underscores how interconnected Earth systems really are. Our oceans, climate, and even coastal biodiversity depend on that silent force. It's almost poetic, this invisible tug that shapes so much of life's rhythm. It serves as a reminder that the systems supporting our existence are delicate, finely tuned, and surprisingly fragile. Humanity, often caught up in grand ambitions, is tethered to these unseen forces, vulnerable in ways we rarely appreciate until they shift or disappear completely. The silent, relentless power of the moon's pull keeps more than just the tides. It sustains the balance of life itself. Impact on Earth's rotation and day length. Without the moon's gravitational pull, the Earth's rotation would experience a dramatic shift. The moon acts like a giant cosmic anchor, tugging steadily at our planet, and over millions of years, it has gradually slowed Earth's rotation, lengthening our days. Remove that gravitational tug, and suddenly, the mechanisms that keep Earth's spin in its current rhythm would be disrupted. Initially, the day might remain unchanged, but over time, unpredictable shifts could occur. Without the moon's influence, the Earth's rotation could suddenly become more erratic, perhaps speeding up or slowing down in jerky, irregular ways, like a spinning top losing its steady spin without the stabilizing finger. The interaction between Earth's rotation and the moon creates a kind of cosmic dance, an intricate balance that maintains the stability of our day-night cycle. When the moon disappears, the primary force breaking the Earth's spin vanishes. This would initially cause a slight increase in the speed of Earth's rotation, making days shorter than the familiar 24 hours. But this rapid change would not be sustainable or stable. Over a longer period, the absence of the moon's gravitational influence could lead to complex feedback effects in Earth's internal dynamics, possibly even resulting in fluctuations in how fast or slow the planet spins. The Earth's core and crust might respond in ways that could cause irregularities in day length, making the concept of a 24-hour cycle an ever-shifting target. Furthermore, the absence of the moon would also destabilize the Earth's axial tilt. Currently, the moon acts like a cosmic gyroscope, helping to stabilize the planet's tilt at approximately 23.5 degrees. Without it, the tilt could wobble wildly over thousands of years, leading to dramatic climate swings. As this tilt fluctuates, the distribution of sunlight across the globe would change unpredictably. Seasons could become more extreme or irregular, and the length of day and night might vary more significantly across different parts of Earth. The delicate rhythm that supports life, shaped over eons by this celestial partnership, would be shattered, leaving the planet in a state of flux and chaos. In essence, the disappearance of the moon would shatter the slow, predictable rhythm of life as we know it. Earth would become a more unstable, unpredictable world, its rotation a chaotic pulse, its seasons a roller coaster. The silent, constant presence of our lunar companion is woven into the very fabric of Earth's natural cycles. Its absence would highlight just how fragile our current stability is, a stark reminder that even the smallest celestial body plays an outsized role in shaping the universe we live in and the life it sustains. The stark realization of our reliance on cosmic harmony makes clear how delicate our existence truly is, floating delicately on the thin veneer of cosmic agreement. Changes in Earth's axial tilt and climate stability. Without the moon's gravitational pull, Earth's axial tilt would become increasingly unstable, like a spinning top suddenly wobbling out of control. Currently, the moon acts as a stabilizing force, keeping Earth's axis tilted at about 23.5 degrees. Without it, that tilt could begin to shift erratically due to disturbances from other planets or random gravitational nudges. Over time, these fluctuations could push the tilt to extremes, sometimes nearly upright, other times almost flat, altering the very foundation upon which our seasons depend. Such destabilization would lead to unpredictable changes in climate patterns. When Earth's axis wobbles significantly, the distribution of sunlight across the planet becomes irregular. Imagine the planet's orientation as a dance that changes tempo suddenly. Some regions would experience prolonged periods of extreme cold because they linger in darkness, while others might face intense heat. The predictable cycle of seasons, which sustains ecosystems and agricultural cycles, could become a chaotic jumble. What was once a gentle, reassuring rhythm of spring, summer, fall, and winter could turn into a series of unpredictable extreme events, with no consistent pattern to follow. The stability of climates on long-term scales depends heavily on the axial tilt consistency. With the moon gone, Earth's tilt would undergo what scientists refer to as chaotic variations, potentially swinging between minimal and maximal angles over thousands of years. Such drastic shifts could cause glaciers to freeze or melt in unpredictable ways, ice caps expanding or retreating without warning. The entire planet's climate systems, oceans, atmospheres, and land, would be thrown into disarray, making life more difficult for plants, animals, and humans who rely on stable cues to survive and thrive. This turbulence in Earth's tilt and climate stabilizes, painting a grim picture of how delicate and interconnected our universe truly is. The moon, often seen as a distant, magical satellite, functions as a guardian of balance, quietly holding these cosmic motions in check. Its absence would expose just how fragile human life really is, like a delicate glass sculpture resting on a thin thread, vulnerable to the slightest tremor. Humanity's future would become a game of adaptation against a backdrop of planetary chaos, reminding us that beneath our confidence lies an intricate web of forces we barely comprehend, yet that hold our fragile world together. Influence on Earth's protective magnetosphere. When a moon vanishes, the subtle yet persistent dance it performs with Earth's magnetic field suddenly ceases, and the consequences ripple outward with surprising gravity. The magnetosphere, this invisible shield enveloping our planet, is partly stable because of the gravitational tug and orbital stability the moon provides. Without its gravitational influence, Earth's rotation and axial tilt could experience shifts, gradually nudging the magnetic field into unfamiliar territory. It's like removing a crucial keystone from an arch. The entire structure becomes more vulnerable, less predictable. The moon's gravity also influences the flow of charged particles captured by Earth's magnetic field. These particles, mainly electrons and protons, are mostly trapped in regions called the Van Allen belts. They're kind of like a magnetic pinch, held in place by the balance of forces. Without the moon's gravitational pull acting as a gentle steward, the shape and intensity of these belts could change dramatically. They might become less stable, or their boundaries could shift, allowing dangerous solar particles to reach Earth's surface more easily. This could amplify the impact of solar storms, leading to more frequent and severe disruptions to satellites, navigation systems, and even terrestrial power grids. Furthermore, the moon's gravitational effects help maintain the stability of Earth's magnetic poles in flux. Absent the moon, the poles might start wandering more erratically, akin to a compass spinning wildly in the wind. The Earth's internal dynamo, responsible for generating the magnetic field, depends on the planet's rotation and internal processes, both subtly influenced by the gravitational interplay with the moon. Over time, the magnetic field could weaken or become more irregular, exposing our planet to heightened levels of cosmic radiation. The protective barrier that shields life from harmful solar and cosmic particles becomes more fragile, as if a mighty but delicate shield is suddenly frayed at the edges. All these shifts point toward a profound vulnerability, a planet that relies on delicate balances, easily disturbed by sudden, monumental changes like the moon's disappearance. The magnetosphere, a complex force field shaped by the interplay of Earth's core, solar winds, and gravitational influences, is far from static. Remove its lunar partner, and it's like removing a vital supporting character from a play. The entire narrative of Earth's space environment could tilt toward chaos. It's a sobering reminder of how interconnected life on Earth truly is. Our existence hangs on fragile threads woven through cosmic orchestration, reminding us that in the grand cosmic ballet, even the smallest change can have colossal consequences for our future. Consequences for satellite and space missions. Without the moon's gravitational pull, the entire framework of human-made satellite navigation and space operations would become significantly destabilized. Satellites orbiting Earth rely on precise calculations that factor in gravitational influences, primarily from the moon, to maintain their trajectories. If the moon vanished suddenly, the delicate balance of these orbits could be thrown into chaos. Satellites that depend on orbital mechanics for position accuracy, such as those used in GPS, telecommunications, and weather monitoring, might experience drift or unpredictable movements. For instance, GPS satellites orbit roughly 200 kilometers above Earth and rely on constant correction signals. Any shift in their orbit could cause errors that ripple across countless devices and critical systems. Communication satellites orbit in specific paths to ensure continuous coverage of their designated regions. These paths are finely tuned to the gravitational forces acting upon them. Without the moon's gravitational tug, the slight but persistent distortions in Earth's shape caused by the moon's pull would disappear, slightly altering Earth's geoid, the shape the planet takes under gravity. This subtle change could shift the gravitational field in ways that impact the firing and correction of satellite thrusters. In technical terms, the disturbance in the satellite's orbital parameters could lead to increased fuel consumption as ground control teams try to compensate for unpredictable orbits. As a result, the lifespan of many satellites might be shortened, and maintaining precise positioning would become more challenging, adding uncertainty to systems that a modern world depends upon every day. Space missions further complicate the scenario. Probes venturing to the moon or planning lunar orbits would lose their navigational reference point. Lunar orbiters, which provide critical data for understanding gravitational interactions and serve as staging platforms, would suddenly have no target or anchor in space. Mission planners would need to rethink entire mission architectures, possibly relying solely on Earth-based tracking, which is less precise and more vulnerable to signal delays. For spacecraft currently en route to or stationed at the moon, this abrupt absence would be akin to someone losing their landmarks in unfamiliar territory, forcing an immediate reassessment of navigation strategies. Over time, this could lead to mission failures or expensive rerouting, with some spacecraft drifting aimlessly or losing contact altogether. The ripples extend beyond the technical into the operational. Operators would face heightened risks of collision or drift from their planned paths, complicating space traffic management. Without lunar gravity's influence, spacecraft in its vicinity might encounter less predictable orbits, increasing the chance of unintended encounters or debris impacts. In essence, the disappearance of the moon would initiate a cascade of uncertainties in the meticulous dance of Earth's surrounding spacecraft. For humans who rely increasingly on satellite data for everything from navigation to environmental monitoring, the sudden absence of the moon would underscore how fragile our technological web truly is, an unanticipated shift in the cosmic balance reminding us how interconnected we are with the celestial bodies around us, no matter how remote they seem. Potential disruption of biological rhythms in nature. When a moon vanishes from the night sky, the impact on Earth's natural rhythms would ripple through ecosystems in ways both subtle and profound. For countless species, the moon's steady glow has acted like a celestial metronome, guiding behaviors that are vital for survival. Nighttime predators rely on moonlight to hunt efficiently, their silhouettes illuminated just enough to detect prey without revealing their positions. Without that gentle illumination, their hunting instincts might falter, forcing them into new patterns that could cascade through the food chain. Conversely, prey animals, finely tuned to the moon's cycles, often adjust their activities based on moonlight, coming out in the dark when predators are less active or hiding when darkness is deepened. The absence of the moon's changing phases would throw these natural clocks into chaos. Moonlight's influence reaches deeper into the biological clocks that regulate the behavior of countless creatures. Many animals, insects included, have evolved to synchronize their breeding cycles with lunar phases. For example, certain coral spawning events depend on specific moon phases, ensuring their offspring disperse at the optimal time for survival. Without the lunar cues signaling the right moment for spawning, these reproductive events might become erratic or altogether fail. This could lead to a significant decline in certain populations, disrupting marine ecosystems that depend on these delicate reproductive timings. On land, some mammals and birds also rely on lunar cues to coordinate activities such as migration or breeding, maintaining a rhythmic balance that has evolved over millennia. At a more subtle level, the moon's presence influences the behavior of plants and soil organisms. Nighttime illumination affects plant movements and growth patterns, especially in species that respond to light cues. The rhythmic opening and closing of flowers, for instance, are sometimes synchronized with moon phases, impacting pollination cycles. Soil-dwelling creatures, from worms to bacteria, are sensitive to changes in night temperature and humidity, conditions that fluctuate with lunar cycles. The disappearance of the moon would cause shifts in these microenvironments, potentially disturbing nutrient cycles and the delicate balance of life beneath the surface. The interconnectedness of these tiny yet vital processes means that even a small change could send ripples outward, affecting entire habitats. Ultimately, the silent disappearance of the moon would mark a profound shift in Earth's biological symphony. Species that have tuned their lives to the lunar rhythm might find themselves disoriented, unable to adapt quickly enough to the new darkness. Over generations, some could vanish entirely, their behaviors no longer suited to a world without that guiding celestial light. It's a stark reminder of how much humanity and nature alike depend on these cosmic patterns, invisible yet deeply woven into the fabric of life. As humans, we often look outward, forgetting how fragile the balance is, how every star, moon, and planet is a silent guardian of the intricate dance of life that sustains us all. Impacts on human cultures and navigation. Without the moon's steady glow illuminating our night sky, the tapestry of human navigation and cultural anchoring would fray in unexpected ways. Throughout history, sailors, explorers, and travelers have relied heavily on the moon, not just for its romantic allure, but as a vital tool in charting courses across vast, unlit waters. The moon's consistent phases provided a celestial clock, guiding navigators through the darkness when stars might be obscured by clouds or haze. Its predictable cycle helped establish latitude estimates by observing the moon's position relative to the horizon, a skill refined over centuries. Remove this luminous guide, and many ancient methods of navigation would become unreliable or outright impossible, forcing humans to depend on alternative, often less precise, systems. Culturally, the moon functions as a powerful symbol tying societies together. It influences calendars, religious rituals, and mythologies. In many traditions, lunar phases mark significant events, fertility rites, harvest festivals, or spiritual observances. With its sudden disappearance, entire calendars would shift or collapse, disrupting social rhythms rooted in lunar cycles. For cultures that center stories around the moon's presence, mythical beings, gods, or spirits, the sudden void would shake their worldview. It's like losing a familiar friend whose presence anchors a shared understanding of time and existence. The moon's absence would create a cultural vacuum, fostering disorientation and a sense of loss that echoes through art, stories, and ceremonies. Navigation, especially in the pre-modern era, was deeply intertwined with the lunar cycle. Navigators used the moon's phases to judge the best times for anchoring, setting sail, or returning safely to harbor. By day, celestial navigation still relied heavily on the stars. By night, the moon was often the dominant guide. Without its glow, the night's landscape turns into a vast, featureless void, eliminating a natural compass that millions depended on. Maritime accidents would likely increase, especially for those venturing into unfamiliar waters. Beyond the physical impact, the psychological toll would be profound. Imagine the unnerving silence of a moonless night, leaving sailors adrift without their familiar celestial landmark. In the broader scope, the loss of the moon would cast a long shadow over humanity's collective sense of stability. Its presence has been a constant, whispering reassurance across generations that nature follows a pattern we can somewhat understand and predict. The abrupt absence would remind us of our fragility against the vast, unpredictable universe. How, despite all our advancements, we are still at the mercy of celestial forces. It's a stark reminder of how intertwined our stories are with these silent guardians in the sky, their gentle glow quietly shaping the way we see ourselves and our place in the cosmos. Alterations in Earth's orbital dynamics. Without the moon, Earth's graceful dance around the sun would abruptly shift gears, throwing its finely tuned orbit into chaos. The moon acts as a kind of cosmic anchor, subtly stabilizing our planet's wobble and orbital path through gravitational tug-of-war. Remove that celestial companion, and the Earth's orbit would no longer be as neat and predictable. Instead, it would become more irregular, experiencing greater oscillations and shifts over long periods. Imagine a spinning top suddenly losing its steady hand. It would wobble wildly before gradually settling into new, unpredictable motions. The gravitational influence the moon exerts on Earth helps dampen the natural oscillations caused by the sun and the Earth's own shape. Without this gravitational buffer, the Earth would become more susceptible to the gravitational pull of other planets, especially Jupiter and Venus. These influences would cause the Earth's orbit to drift slightly, stretching and compressing in ways that could profoundly affect our climate. Seasons might become more erratic, with some regions experiencing prolonged droughts or unexpected frosts. The stability of Earth's orbit, its shape and tilt, would suffer, shifting from its current nearly circular orbit and consistent tilt of about 23.5 degrees. These changes aren't just theoretical. They could destabilize climate systems that have existed in a delicate balance for thousands of years. Furthermore, the lack of a large, nearby moon means the Earth's axial tilt, responsible for creating seasons, would be less stabilized over time. The moon's gravitational tug helps maintain that tilt, acting as a cosmic gyroscope. Without it, gravitational interactions with the sun and other planets could cause the tilt to wobble more dramatically. Over centuries, this tilt could shift back and forth, sometimes making summers scorchingly hot, other times bringing frigid cold, all while seasons become less predictable. Think of it as trying to walk steadily on a tilting surface. Each step becomes more uncertain, more prone to slipping. Our current climate balance is a fragile one, and removing the moon would tip that balance into chaos. In the grand tapestry of the cosmos, Earth's orbit is a finely woven thread, kept steady by a tiny yet mighty partner in the form of the moon. Its sudden disappearance would unravel that thread, leading to unpredictable twists and turns in Earth's celestial path. The stability of life itself hinges on these subtle gravitational dances, often unnoticed until disrupted. Humanity's existence relies on this fragile harmony, an intricate balance that, if broken, could send Earth's climate and biosphere cascading into disarray. It's a sobering reminder of how delicate and interconnected the universe's choreography is, and how vulnerable we are in the face of cosmic forces beyond our control. Effects on Earth's geological activity. Without the moon's gravitational tug, Earth's geological heartbeat would change in profound and unpredictable ways. The moon plays a crucial role in stabilizing our planet's tilt, which in turn influences tectonic dynamics over millennia. Its gravitational pull creates a subtle but continuous force that helps maintain the stability of Earth's axial tilt, preventing wild swings that could lead to catastrophic climate shifts. Without it, the planet's tilt could wobble more dramatically, potentially triggering more intense earthquakes and volcanic activity as the crust adjusts to the new equilibrium. Seismic activity could intensify, as the absence of lunar gravity removes a significant stabilizing influence on Earth's crust. The constant, gentle tug the moon applies acts like a calming hand, slightly easing the stress in tectonic plates. Without that pull, plates may experience increased lurching, slipping unexpectedly and with greater force. Earthquakes might become more frequent or severe, especially along fault lines that already carry significant tension. Volcanoes, which are often linked to crustal movements, might also become more active as the Earth's internal heat and tectonic stress find new pathways for release. The very landscape we see today, mountains, valleys, and fault lines, could shift sense of permanence as the Earth's surface reconfigures in response. The oceanic crust interacts with the mantle through processes of subduction and convection, which are driven by heat and gravitational forces. The moon's gravity not only creates tides, but also indirectly influences these deep-seated movements. With the moon gone, the tidal forces would diminish drastically, causing less flexing of the Earth's crust. Ironically, this reduction in tidal stress may seem like a calming influence, but could lead to an accumulation of stress within tectonic plates. Over longer periods, this might cause episodic bursts of seismic activity, similar to how a stretched rubber band breaks after being pulled too taut. These shifts could reshape coastlines or even trigger larger-scale crustal reorganizations, with unpredictable consequences. The Earth's internal convection currents, responsible for slowly dragging plates across the surface, are sensitive to changes in external forces. The lunar influence, subtle as it is, helps keep these convection currents in a relatively steady state. Without the moon, the energy balance within the Earth could tilt, literally, and the convection patterns may become more erratic. This wouldn't happen overnight, but could gradually lead to a more tumultuous geological environment. In essence, the moon acts as a moderator, dampening the wild fluctuations of Earth's inner engine. Its sudden disappearance might send Earth's geological activity into chaos, a silent reminder of how interconnected and delicate planetary systems truly are, and how fragile the harmony of our world can be in the absence of a quiet, steadfast companion. Environmental ramifications of moon loss. Without the moon, Earth's delicate balance of environmental systems would unravel in ways that are hard to fully grasp at first glance. The moon's gravitational pull is subtly but persistently tugging at our planet, stabilizing its rotational wobble. Without it, Earth would begin to spin more irregularly, causing unpredictable shifts in day length and seasons. This would be akin to a spinning top suddenly wobbling wildly, disrupting the rhythm that life on Earth has relied on for millennia. The cycles of the moon directly influence tides. With no lunar pull, ocean tides would diminish drastically. The vast, rhythmic rise and fall of tides, shaping coastal ecosystems, distributing nutrients, and supporting marine life, would vanish almost overnight. The loss of tides would not just be a matter of disappearing waves. Coastal environments, some among the most biologically productive regions on our planet, would face catastrophic collapse. Estuaries, which serve as nurseries for a significant portion of marine species, rely heavily on tidal flows to bring in nutrients and oxygen. Without this pulse, many species of fish, mollusks, and crustaceans would struggle to survive or reproduce. Coral reefs, intricately linked to tidal rhythms and nutrient exchange, would suffer from stagnation, leading to widespread bleaching and die-offs. The entire oceanic food web would feel the tremors of this disturbance, cascading into a decline in fish populations and affecting human communities that depend on fishing industries. This shift wouldn't stay confined to the oceans alone. The climate patterns that govern weather and rainfall across continents are intricately tied to ocean currents and tides. When the moon disappears, the dampening effect of tidal forces on ocean circulation patterns would fade. The resulting imbalance could lead to more extreme weather, more intense storms, prolonged droughts, or unexpected flooding, even in regions far from a coast. Without the moderating influence of tidal-affected currents, the atmosphere's stability could be compromised, throwing climate systems into chaos. Entire ecosystems, from rainforests to arid deserts, depend on predictable weather, and the moon's absence would make this predictability disappear, plunging Earth into an unpredictable environmental tumult. On a deeper, more poetic level, the moon has long been a symbol of stability and gentle guidance in human consciousness. Its disappearance would devastate not only the physical environment, but also the emotional landscape of humankind. We count on the moon's quiet presence, not just for its influence on tides or night navigation, but as a constant, an anchor in the night sky that has helped structure life, mythology, and culture. Its sudden vanishing would serve as a stark reminder of how fragile the web of life truly is, and how interconnected we are with celestial forces beyond our daily perception. The environment would enter a new, uncharted chapter, one where Earth's rhythm is forever changed, and with it, perhaps, much of what makes life on this planet resilient and beautiful. Long-term planetary evolution and stability. Without the moon, Earth's long-term planetary stability would take a profound hit, setting off a cascade of consequences that ripple through the fabric of life itself. The moon acts like a cosmic anchor, subtly tugging on Earth's rotation and shape. It's responsible for damping the wobble in our planet's axis. Think of the wobble as a spinning top that's trying to stay upright, but wobbles when it's unstable. Without the moon's gravitational pull, Earth's axial tilt would become far more volatile over millennia, oscillating wildly as it struggles to find a new equilibrium. This tilt is what gives us our seasons, and without the moon's stabilizing influence, those seasons could become unpredictable, lasting longer or shorter, more extreme, or even erratic. Such chaos could gradually degrade the stable climate patterns that civilizations have depended on. The gradual shift in Earth's rotation rate would accelerate, changing the length of days in ways we can scarcely imagine. Currently, the moon's tidal forces act as a brake, slowly slowing Earth's spin over billions of years. But if the moon vanished, the tidal interactions would weaken dramatically, and Earth's rotation could become more irregular. Days might grow shorter or longer unpredictably, destabilizing ecosystems that have synchronized their life cycles to the familiar rhythm of the 24-hour day. Without the stabilizing presence of the moon, Earth's internal dynamics might also shift. Change in the flow of molten iron in the core could arise from altered gravitational conditions, possibly affecting the magnetic field that shields us from solar wind and cosmic radiation. The magnetic field's strength and stability owe much to the heat and convection currents in Earth's core, which could be influenced over eons by the absence of lunar gravitational tides. The stability of Earth's orbit itself could be compromised. While the moon isn't the sole factor maintaining Earth's orbital path, its gravitational influence adds a layer of stability, preventing slight nudges from planets like Jupiter from causing large orbital shifts. Without this buffer, Earth's orbit might experience more pronounced variations. Over hundreds of millions of years, such fluctuations could push the planet closer to the sun or tilt it into a more elongated orbit, making the climate even more unpredictable. In essence, the absence of the moon could turn Earth into a restless wanderer in space, more vulnerable to the gravitational whispers of neighboring planets and the sun's influence. Humanity's future depends on the delicate dance between planetary forces that have kept Earth hospitable for millions of years. The moon's quiet gravitational embrace has been a guardian of stability. Its disappearance would be a silent but catastrophic reshuffling of planetary mechanics. As we stand under the sky, pondering the celestial bodies that shape our very existence, one can't help but feel how fragile this balance truly is. The moon is more than a shining companion. It's a silent pillar of stability in a universe brimming with chaos, reminding us of our delicate, fleeting sanctuary in a universe that shows no mercy for neglect or hubris. Implications for future space exploration. If the moon were to vanish suddenly, the ripple effects on future space exploration would be profound and far-reaching. Without the moon's gravitational influence, Earth's tides would diminish drastically, oceans locking into a more static state, less rhythmically stirred by lunar tug. This change might seem irrelevant at first glance, but it would actually have serious consequences for space agencies planning launches and orbital experiments. The stability provided by the moon's gravity was already a factor in precise satellite positioning. Without it, navigational systems and precision-guided missions would need significant recalibration. We might even see increased orbital debris due to less predictable satellite behavior, making space junk management more complicated than ever. The disappearance of our natural satellite would also strip away a fundamental testing ground for technologies and theories that underpin our understanding of celestial mechanics. The moon serves as a nearby laboratory for testing landings and surface operations, preparing us for missions to Mars and beyond. Without it, the leap to larger, more distant destinations could become more daunting. Think of the moon as a stepping stone. Its absence leaves future explorers without a familiar, manageable environment to test propulsion systems, habitat technology, or resource extraction methods close to home. This would push agencies to find alternative, possibly more expensive or risky, ways to develop these capabilities on other celestial bodies, which are often less well understood and more hazardous. On a conceptual level, losing the moon would significantly impact international cooperation and the spirit of collective human curiosity that fuels space exploration. The moon has historically been a unifying goal, a shared target that brought together nations and commercial entities alike. Without that common goal, space exploration might become more fragmented, each country pursuing isolated projects rather than pooling resources to conquer larger challenges. The sense of wonder and aspiration inspired by lunar missions would fade, possibly stalling efforts to inspire a new generation of scientists, engineers, and explorers. In its absence, the human drive to reach beyond our planet might slow down, replaced by a somber acknowledgement of our fragile, fleeting foothold in the cosmos. Even more emotionally, the void left by the moon would serve as a stark reminder of how delicate planetary systems are. The moon's presence has anchored our night sky and contributed to the stability of Earth's climate and biosphere for eons. Its sudden disappearance would symbolize how unpredictable and fragile life on Earth can be when faced with cosmic upheaval. Space exploration, now driven by a desire to understand and protect that fragile planet, might shift focus towards safeguarding what's left from future catastrophic events. The lunar absence could ignite a deeper sense of vulnerability among humanity, an awareness that paradise isn't guaranteed and that every piece of our celestial neighborhood holds significance beyond just scientific interest. Without the moon, Earth's delicate balance would unravel in ways both subtle and catastrophic. The moon's gravitational pull acts like an unseen hand gently tugging at our planet, shaping the ocean tides that synchronously rise and fall, creating a rhythmic heartbeat that sustains countless coastal ecosystems. Remove that gravitational influence, and the tides would diminish dramatically, potentially fading into mere ripples or vanishing altogether. Without these tidal cycles, beaches would lose their rhythm, tidal pools would dry up, and marine life adapted to this dynamic dance could face sudden extinction. Beyond the tides, the absence of the moon would significantly destabilize Earth's axial tilt. Currently, the moon helps stabilize our planet's wobble. Think of it like the gyroscope that keeps a spinning top steady. Without this stabilizing force, Earth's axis would tilt unpredictably over thousands of years, swinging from nearly upright to at extreme angles. The result? Climatic chaos. Some regions might experience relentless ice ages while others cook under relentless heat. Seasons would become unpredictable, and the delicate balance necessary for supporting diverse life forms would falter. The very face of our planet would become a chaotic patchwork of environments, making life's continuity uncertain. Moreover, the cultural and ecological impacts extend deeply into the night sky. The moon's absence would deprive us of one of the most visible and iconic celestial bodies, altering the way humanity perceives the cosmos. Nightless nights or nights with vastly dimmer skies would become the norm in some areas, stripping away a source of inspiration and wonder. For nocturnal animals, this change could be devastating. Many species rely on lunar cycles for navigation, reproduction, and foraging. Without the moon, their behaviors might become disoriented, leading to further ecological imbalances. The dark hours would no longer serve as a tranquil shadow, but as a confusing void. The emotional toll on humanity would be profound. The moon has long been intertwined with human culture, myth, and art. Its disappearance would mark not just a planetary event, but a cultural rupture, one that reminds us how fragile and interconnected our existence truly is. Our reliance on celestial rhythms reveals a deep, unspoken connection to the universe's natural order. When that order is broken, it's as if the foundation of our cosmic story crumbles. The night sky, once a constant that grounded and inspired us, would become a blank expanse, an emptiness that symbolically echoes our own vulnerability in the vast universe. As we begin to imagine a world without the moon, the truth becomes clear. Our planet's rhythm is deeply intertwined with its silent sentinel in the sky. The moon's gravity not only holds the oceans in check, but also stabilizes Earth's tilt, shaping our climate and seasons. Without it, tides would vanish, storms could spin out of control, and our delicate balance would unravel overnight. The gentle glow that guides us through the night would be replaced by an endless darkness, plunging us into chaos that we can't even fully grasp. This thought experiment reminds us how fragile and interconnected our existence truly is. Our planet, with all its complexity, relies on a cosmic partner we often overlook. It's a humbling reflection, how vulnerable we are, how much we depend on forces beyond our grasp. Yet, it also sparks hope, urging us to cherish the delicate beauty of our world while we still can. If you want to explore more mysteries of space, nature, and what keeps us worlds turning, stay tuned for upcoming videos. Share your thoughts below. What would you miss the most if the moon suddenly vanished? Because understanding our universe is a journey worth taking together. And maybe, just maybe, it'll remind us to look up more often and appreciate the fragile, brilliant life we have here.